Hello there, I'm Thomas Hatsios, German-American pilot flying the Boeing 787-900 to 95 from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900. The aircraft. I'm gonna start with the primary flight display. The display is the airspeed indicated, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the barometric pressure of the outside atmosphere, and the target altitude selected from the autopilot and flight director system panel. We have also the altitude indicator with the pitch ladder decrease and the bank angle decrease, the artificial horizon, also the ILS localizer, the horizontal localizer, and the vertical glide slope. We have the transmitters from the runway antennas that are received from the onboard antennas of the aircraft, and this way it displays the horizontal and vertical localizer, glide slope, and localizer. We can use it to align the airport runway. So we're gonna use the runway 14 in Zurich International Airport, the Lszh, and you're gonna see how we're gonna use the ILS localizer, the instrument landing system of the airport. We're gonna use also the magnetic North Pole heading of 136 degrees for runway 14. So you're gonna see also we have the angle of attack of the aircraft as it flies, and the flight mode gonna see the autopilot and the auto throttle, later on vertical navigation modes. We have also the navigation display. The navigation display the displays. We have the HSI in the primary flight display. We did the graded flight plan display. We have also the navigation display. The navigation display that displays the GPS position, the terrain and weather reflections from the weather radar. You can see the terrain map also with the airports where you are located. So we're gonna use the airport, the Zurich International Airport, runway 14 in Switzerland, in the Lszh, and you can see the airport for four-letter name, and also the runways we're gonna use for takeoff and for landing. As displayed in the navigation display, you can see the heading of the runway, the orientation, its length. So you can see also other airports. You can see other navigation aids in the display. So you can see here we have the primary flight display, the navigation display, the ACAS, engine indication control lift system display, the engines display, the flight management computer. So I'm gonna start showing you all the instruments one by one of the Boeing 787. Then we're gonna make a complete flight from takeoff, climb, cruises, and approach and landing. So I'm gonna show you also you can see the navigation display. We have the navigation aids, the workstations, the ADFs, the waypoints, which are horizontal and vertical navigation fixes the aircraft can fly through. So we're gonna make this flight. We're gonna use the flight management computer to create a flight plan or a flight path or a route for this aircraft. So you're gonna see how we're gonna create that flight plan. And the aircraft, when it's gonna be flying, is gonna cross through some waypoints. We're gonna select using the flight management computer. So we have also the workstation, the ADFs, and the Bs. You can see other aircraft that fly around you using the transponder, the DSP and ADC transmitter receiver that transmits our frequency to other aircraft, and the air traffic control and receives from other aircraft and displays them in the navigation display. You can see the other aircraft with a diamond shape, the distance they are located from our aircraft, the altitude difference from our aircraft. Also, this computer can calculate using the radio frequencies the other aircraft airspeed with respect to our aircraft, and it will give us warning using the TICA system, the traffic collision advisory system. You will see an evasive maneuver advisory in flight if we have an incoming collision with another aircraft. So we have also, as I told you, the horizontal and vertical profile of the terrain around you. You can see how far above you find from the terrain where you are airborne. You can see the magnetic North Pole and the geographic North Pole and the magnetic variation depending where you are on the world, the magnetic heading and track. and also other features. You can see the ground speed and the wind direction and speed. So I'm gonna show you the navigation display. Then we're gonna make over here a few more instruments to see. The autopilot flight director system panel, the FS panel, flight management computer, thrust levers. I will show you how to use the thrust levers over here to actuate, increase and decrease the thrust produced by the engines of the aircraft. So we're gonna have also the flight controls. You're gonna see how we're gonna use these flight controls here. I'm using this side stick to control the flight controls of the Boeing 787, so we can climb and descend, we can make turns in flight. Also use the rudder pedals for the vertical tail, the rudder, as you can see. So I'm gonna show you how I'm gonna input the navigation display. The flight plan I will use the data of the aircraft, the takeoff, gross weight, that includes the empty weight plus the passenger, plus the cargo, plus the fuel on board, where the fuel is stored in the left and the right wing, in the center tank. The flight management computer is going to make calculations, so we have 30% of fuel in the left and the right wing tank, and 10% the center tank is going to calculate the center of gravity using the fuel on board and the loads from the compartments and the passenger. So it will give us the center of gravity in terms of the mean aerodynamic core position of the Mach. That is 23% of the fold of the forward wings is the position of the maximum aerodynamic lift occurs in the forward wings. Is the position also where the stall will begin as we fly. The airflow will become detached from the top surface of the wings, and the aircraft may gonna start off. Also, we need to monitor over here. We have the airspeed. We have to monitor all the time. The airspeed is always above the stall speed during flight. So you'll see the airspeed like 200 knots. You'll see the stall speed down here with a yellow and red indication. So other airspeeds also, you can see also the altitude, barometric altitude above the sea level. You can see the barometric pressure for the barometric altitude, 29.92 inches of mercury. Over here the minimums radial altitude, we are 2 feet above the ground, so you can set over here the barometric pressure of the outside atmosphere using these switches in inches of mercury or hectopascals. Instead of pressing this switch, you can set minimums, radial, the plan switching, the range. You can change the range and the switching of the navigation display of the maps over here. We have some warnings: accept, cancel, or reject, and WXR weather radar, traffic and terrain on the displays over here. So this is the FS panel, electronic flight instrument panel. We have some systems, also indications, info, CDU, checklist, communications, ACAS, engine, cancel. So you can see we have many buttons in this aircraft, many switches. Also in the flight management computer over here, as you're gonna see later when we're gonna create the flight plan over here. So you can see the alphanumeric here, keyboard for inputs, and the modes we're gonna select. Also the autopilot flight director system panel. So I insert all the data as I told you: takeoff, gross weight, the left and the right wing, fuel on board 30%, center tank 10%, 30% the left wing, 30% the right wing. We will calculate the center of gravity as we fly and burn fuel. Also the center of gravity is recalculated because it's shifted. So we have in aerodynamic core position about 23% of the Mach. That also will give us the horizontal trim stabilizer for takeoff about 4.25 degrees. So you will see the horizontal tail trim stabilizer for takeoff. I forgot also to mention here in the primary flight display, we have airspeed, barometric altitude, target airspeed, target altitude. This needle is the vertical rate of climb descent of the aircraft. So you see this white needle, like 500, 1000, 1500, 2000 feet per minute climb or descent is the vertical rate of climb descent of the aircraft. The vertical speed indicator, or VSI, this tape here. This is the pitch ladder over here. is 2.5, 5, 7.5, 10 degrees, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down altitude. So you need to pay attention to both. If you have a positive altitude but the aircraft might be falling down, so you have to pay attention to this needle also. This is the bank angle in flight, how steep bank angles you make. Also this is the heading 360 degrees, so the purple values are the ones selected from the autopilot flight director system panel over here. You can see autopilot engaged, disengaged, the airspeed guidance, heading guidance, and the altitude and the vertical rate of climb descent of the aircraft. We have many modes, the auto throttle, flight director, autopilot disengaged, and autopilot engaged. Over here you can see also like other modes, flight level change, VNAV and LNAV, climb continuous, auto throttle. So we're gonna set the airspeed, heading, vertical rate of climb descent over here, and the altitude, roll localizer, approach throttle, and later in other modes you will see them displayed over here in a different mode. We have takeoff, go around also. Um, Also the head-up display over here, you can see displays same things like the primary flight display, all the indication as we define. So you will see we're gonna use, as I told you, the values: takeoff gross weight, the minimum dynamic core position, horizontal trim stabilizer, the fuel on board, the passengers and the cargo. Is gonna calculate the center of gravity. We're gonna input also the flaps for takeoff. We're gonna use 15 degrees of flaps for this flight. You're gonna see I'm gonna use the flap over here. 15 degrees is gonna display over here in the icon. So I will show you how to use also the flaps and the speed brakes. We're gonna insert also other data for this flight using the flight management computer. When we're gonna create the flight plan, I'm gonna insert also the runway information. We are in the Zurich International Airport. We're gonna use the Lszh airport in Switzerland. Zurich International Airport, and runway 14, both for takeoff and for landing. So I'm gonna insert the runway information and the ILS localizer, the instrument landing system, for takeoff and for landing. So creating the flight plan, I will insert the info of the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature, and also whether the runway is dry, wet, or ice. And we're gonna have the takeoff speeds, the V1, V rotate, and V2, using all the information I aforementioned. Using the flight management computer, we're gonna input also we're gonna rotate it with 9 degrees and 15 degrees of flaps at about 150 knots, and we're gonna have actually a bit less than that, maybe 135, 140 knots. Then we're gonna have about 155 knots, the V2 plus 50 knots, which is the climb speed. We're gonna have also inserting the flight management computer the seeds. The seeds are the standard instrument departure waypoints and fixes that include horizontal vertical indication fixes for the initial climb of the aircraft. We're gonna have the climb to the cruise level. We're gonna cruise at 25, 26, 27, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints again. Then we're gonna start the descent. We're gonna have the double descent and approach for landing again to the airport. We're gonna have the stars at the terminal arrival waypoints and fixes for the terminal approach of the aircraft. So you're gonna see how we're gonna use all the terminal arrival waypoints and fixes. And we're gonna have also the ILS localizer, the instrument landing system for the airport inserted in the flight management computer. So I will insert all this information. The stars is at the terminal arrival waypoints and fixes. You will see the stars displayed in the navigation display. Also the ILS localizer, we're gonna use the instrument landing system that transmits radio frequencies from the runway. Antennas which are located in the threshold of the runway, and receives from the aircraft using the onboard antennas, and calculates the horizontal and vertical deviation from the runway. And we use it for alignment of the runway as we fly. We can have the Lszh localizer tuned either automatically using the flight management computer or manually. We're gonna use the navigation radio, the radio management panel with the RMP. So you're gonna see both ways. We have the magnetic heading, magnetic north pole heading of 136 degrees for the runway 14 in Zurich International Airport in Switzerland. We're gonna use for landing, also as for takeoff. We're gonna use 15. We're gonna use 30 or 35 degrees of flaps for landing. 9 degrees speeds up attitude as we are approaching for landing. Also, we're gonna have about 160, 170 knots of airspeed, and the landing gear extended, and 9 degrees of pitch attitude for approach and landing. So you're gonna see also that. So I'm gonna show you a couple more things. The flight management computer over here, the outside view of the aircraft again over here. So I will talk to you about Newton's physics, aeronautical and aerospace engineering, and derive some principles about the aircraft as we're gonna be flying. You will see over here we're gonna have as you can see, so you can see here we have the exterior view of the aircraft. So I will talk to you about the Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know when flying the aircraft. So you can see the aircraft wings hold the weight of the aircraft as the aircraft flies, using the thrust of the engines to move it forward, since this is a passenger aircraft. And we have also the vectors from the engines. We have the minimum dynamic chord position, about 23% of the Mach is pretty much here, where the maximum dynamic lift occurs in the forward wings, where also the stall will begin the top surface of the wings. The airflow becomes detached as we fly. We need to avoid that. We have over here in the Mach is where it transverses the vertical axis, the center of gravity, pretty much the longitudinal axis from nose to tail. You can see the longitudinal axis transverses also the vertical tail and the horizontal tail, this axis here, so we can climb and we can descend the aircraft and make turns in flight to the right or to the left. Also use the ailerons and the spoilers for deflection, for airflow deflection, using Bernoulli theory of fluid and Newton's physics. So you can change direction using the flight controls here, as you can see. So you can climb the semic turn. You can see also we have, as I told you, longitudinal axis from nose to tail. We can pitch stream. I will show you later the pitch stream stabilizer, the horizontal stabilizer. We can pitch stream the tail of the aircraft up and down, or the elevator as we fly, to make the aircraft more balanced and stable in flight. You can see also we have the lateral axis from wingtip to wingtip. We can climb and descend using the elevator through the lateral axis, make bangles around the longitudinal axis. This axis make a roll, and the vertical axis is for using the rudder for making turns left and right, using the rudder. So we have also the the wings of the aircraft over here. You can see the bottom surface of the wings is more flat. As we fly, we have the curvature from the flaps extended, and we take an angle of attack. So the airflow is moving slower below the wings, so we have higher pressure, which pressurizes the aircraft wings and weight up into the air. As we accelerate, we have higher airspeed, we have more lift from the wings. Also, you can see the top surface of the wings. So this is from the Bernoulli theory of fluids. Also, you can see it's more curved, so the airflow is moving faster above the wings, so we have lower pressure above the wings, which creates which sucks the aircraft weight and wings up into the air. So this is the Bernoulli theory of fluids, and some aeronautical and aerospace engineering we need to know when flying the aircraft. So I will show you also the flight controls maybe right now, then how to use the flight management computer. So So we use maybe the flight controls first and flight management computer. So we'll start with the flight controls. Also, you also here we have the horizontal trim stabilizer. Over here you can use these trim switch. You can see trim horizontal uh, elevator trim. Left click down, right click up. So right click, so you can see elevator trim. So this way you trim the nose of the aircraft down, and this way you trim it up by trimming. You pitch up the nose like this, and you pitch down the nose like this by trimming the horizontal stabilizer of the elevator of the aircraft. So this is a stabilizer trim as we fly, very important because it trims this horizontal tail as we fly to make the aircraft more balanced and relieve the air pressure from the flight controls. So you can see how many degrees you trim here in the display in the ACAS and the indication crawler system display. Nose down and nose up over here, 4.25 degrees. We have also cabin altitude outflow valves. We're gonna use here the outflow valves later. So we have also this guarded switch. It's for all Boeing 737, 747, 757, 767, 777. It's the L2 stabilizer switch and R2, left 2 and R2. So we have a failure that affects the hydraulic system of the L2 and R2. That affect the auto trim from the autopilot flight director system panel and the flight management computer and the auto flow, the flight by wire system and the flight control computers. We have to turn off for normal cut off this switch, and then use this switch over here, the alternate or the manual. So we have always manual trim switch. You can see nose up and nose down. You can trim, elevator trim left and right. So we have also other things here. You can see the parking brakes, the switch. So you use the manual trim over here after you disconnect, as I told you. So you see we have failure of hydraulic systems over here. This is the hydraulics and affect the horizontal tail stabilizer system that is used by the auto trim from the flight control computers. We have the flight control computers also here. You can see primary flight control computers. It will affect, you disconnect from normal to cut off, you open the guarded switch and use only the manual trim over here. So you have also a couple more things to see. You can see the flaps position over here. Extend, now it's retract. You move the handle up in the position you want, or extend like 1, 5, 15, 20, 25, 30 degrees over here. So you'll see how many degrees you have it here. You change the position like this, you'll see it's moving the flaps. Now it's 30 degrees, it's down. So this is what this handle is doing, and you see the flaps are fully extended in both wings like this. So we have also the speed brakes, which are secondary flight controls, the thrust levers also. So I will show you how to use all the flight controls of the Boeing 787. In the flight simulator I use this side stick, so it controls the yoke of the Boeing 787 for climb and descent, also the ailerons and the spoilers for making bunkers left and right, and the flaperons using the control wheel. So we use the control column for climb and descent, and the rudder pedals for young turns using the vertical tail the rudder, and also for nose wheel steering the ground, and for toe brakes. So you can see also we have the horizontal trim stabilizer and the thrust levers command inserted also here. um, so you will see how I use the side stick right now. You can see we can climb like this, you can descend, so you can climb, descend like this. You can make also turns to the left and turns to the right using the control wheel. Over here is the control wheel for making turns like this, right and left. This is the control column, it's for climb and for descent, and the rudder pedals for the rudder over here, and for nozzle steering. Also they are interconnected with the tiller. In the ground that is still like 70 knots. Also the rudder is effective aerodynamically from 4 to 5 knots. You can see both sides are moving together. They are interconnected and move together in flight, not like in the Airbus where you have size priorities. So you can see also the outside view. I'll show you a little bit. Then going for the flight management computer. So you can see also the thrust levers here. We have the thrust levers. So you see the thrust levers over here moving forward and aft. You will see indications from the engines over here. Increase or decrease left and right engine. The thrust commanded now in the idle. So I will show you one more view of the Boeing 787. In this way I will show you how to control again the flight controls using the Boeing 787. So we have the Airbus side stick over here for controlling. So we can climb and you can descend again. You can see a better view, make turns to the right and to the left. So hope you like it. So you climb like this, descend. Quite easy, very fast. You can leave neutral, you can make turns again. So this is the best way. All side stick deflection, full left, full forward, full right, full left, and the rudder pedals also. The thrust levers, as I told you over here. You can use together with the flight controls. Also a little bit the outside view, so you will see again how you climb over here using the horizontal tail for climb and for descent. Also make turns to the right, turns to the left. Also you can use, as I told you, the ailerons and the spoilers, as you can see. So we have full flight controls like this. Also you can see we can retract the ailerons and the spoilers. So this is all the flight controls we need right now. I will show you also the flight controls lessons right now. So you can see all flight controls are moving together. Side stick deflection is proportional and both sides are interconnected, as I told you. Side stick deflection now propulsion of the yoke. All flight controls are fly-by-wire system. So they are electrically controlled by the flight control computers over here. Primary flight control computers, normal and alternate mode, and we have the direct mode also. So they are hydraulically actuated. I will show you later how using hydraulic power. So I'll show you a little bit more of the Boeing 787 systems. Right now we'll go to make the flight management computer, the flight plan. Then I'll show you the pilot flight director system panel, the engines, and make an engine start demonstration. Then after all these systems explanation, I will show you, I will make a complete flight from takeoff, climb, cruise, descent, of course, and landing, full manual. So stay with me until the end part of the video. So we go over here in the control quadrant. So you can see also the pedestal, the engines here, the mouse pad, another view of the cockpit. So make a little bit maybe faster, as you can see. So you can see we have the modes here, the index. You can use either mode from the initial reference, like identity, position, performance, takeoff, approach, annunciate status, navigation data, flight plans, load air traffic control plan, load plan, save flight plan. So we have identity, Boeing 787 900, as you can see, IRAC cycle, and position where we are located. We're gonna use the reference position. Lszh, it's over here. Zurich International Airport. Lszh, it's in Switzerland. We have the coordinates, GPS position over here, nearest one. So go back to the index, like performance, takeoff, gross weight, fuel on board. So we're gonna use first the origin, departure, and arrival airport. From this airport, Zurich International Airport, back to the Zurich International Airport, copy paste, clear over here, runway 14 for takeoff and for landing. So we go here, departures and arrivals, set up the flight plan. You can use either runway 14, 10, 16, 28, 32, as you can see here, and neither one seats the instrument departure. So we're gonna use runway 14, Trans-Zui over here, the seats, the other instrument departure, waypoints and fixes. You're gonna see them later, displayed as stars. Also arrival, select either approach. You can use either runway 16, 28, 34, VOR or ILS. ILS 14, 16, ILS 28, ILS 34, GLS 14 localizer. We have a GLS system, as you can see. So maybe we're gonna use the ILS 14, Trans-Amity. It's a waypoint in flight, Trans stars Negria over here, Negria 1 Alpha. So you're gonna see how we're gonna create the flight plan. Now we have it created already, using the seats and the stars and the takeoff and approach runway. Cancel discontinuity here. We have to initialize 0 fuel weight 322.7 plus fuel on board 34,800, total gross weight 357,000.6 pounds. So we confirm that. Reserve fuel 5% for this flight. Cruising altitude 25,300 feet. Cost index 100%. Fuel freezing temperature minus 37 degrees Celsius. So we have to recirculate and heat up the fuel in flight. Cruising center of gravity to 88%. So we activate that, we execute, and this activates the flight plan. The green switch over here, you're gonna see the purple now displayed, and we have an active flight plan in the display, computed, top of the sun. So you can see the first waypoint after takeoff, 135 degrees, same like runway heading. Intercept to nautical miles, 250 knots, 1,900. Then TRO 96, 250 knots, 3,290, 2,500, 250, 2,500. Intercept again, 250, 5 nautical miles. Zui 062 would change direction here. We make a left turn, 6 nautical miles, 302 knots, 6,000 alpha. So this is the course of the aircraft in flight, the flight plan or flight path or route, Nigra 071 degrees, 26 nautical miles, 302 knots, flight level 22, 22,100, Mativ 230 degrees, 12 nautical miles, 320 knots, 11,800, Amaki 250 degrees, 6 nautical miles, 109 knots, 10,400, Zui 9 nautical miles, 180 knots, 7,000 alpha. So we're gonna make a left turn, maybe Z8, we make a right turn here, then another left turn, change direction, Z8 701, 180 knots, 6,000 alpha. This is the descent and approach for the terminal, starter terminal arrival waypoints and fixes, the stars, TRA 108 knots, 5,000 alpha, CI14 180 knots, 4,000 alpha, Osnem 136 degrees, 170 knots, 4,000, runway 14, approach and landing 140 knots, 1,400. So we use flaps 15 degrees, center of gravity 28%, 4.25 degrees as you can see here, and we have the takeoff speeds V1, V rotate and V2 for this gross weight and runway. So we have maybe index departure arrivals, alternate, VNAV, progress, FMC communications, hold, you can hold other waypoint here in flight. We have the fix and the navigation radio as you can see, so we can tune the Lszh localizer here or at all the voice station. So this is what we needed to do using the flight planner. We have a few more minutes to go for this flight. So you can see here we have the displays. As I told you, we have the flight plan here created. You can see the purple line is also displayed in the SSI. We're gonna change a few values. You can see the runway and the position of the aircraft. We're gonna use this runway from takeoff over here, climb, cruise. Here's the approach and landing. You can see also the vertical profile. You're gonna see how far above we're gonna be climbing and flying above the ground. You can see the ground with the yellow, green or red colors, and also if we look closer, you see the runway here with the GPS position, the taxiway in front of us and the other runway. So you can see everything is the same like on the GPS display over here. The runway and the taxiway we're gonna use for takeoff. Over here we are positioned in the right we are in the right position right now. Also you can see the terrain in front of you. Have some mountains over here. As we're gonna be flying, you can see the mountains in front of you, the distance they are located, in the vertical deviation, also in the horizontal. As you've been flying, you can use also the center display like this. You can see here as we're gonna be climbing, a little bit better view of the flight plan. Over here we're gonna be climbing the runway, then we're gonna cruise over here, as you're gonna see further away. Also the vertical over here, profile of the flight. You can look further away, you can see over here is Germany, here is France, here is the Switzerland. You can see the waypoints we have to be flying in the map. Also here other indications, pretty much the same. So this is for navigation purposes. Also you can see the plan display over here, other airports, what you can do with the display. Also the elevation of the terrain here, 4,700, 1,600. The airports, you can look closer or further away, you'll see more airports in the GPS receiver. You can see the runway, as I told you, the one is beside us. We're gonna taxi and take off in a couple of minutes. How far away we are from the taxiway. Also the engines indications I will talk to you about in a couple of minutes. So this is the navigation display. Displays, you can see the stars over here. TRAs, the arrival stars, also the takeoff, the seats. One TRA, C1, 1.4 is also known. It's the same like here in the flight management computer we just created. Also here, so you will see both horizontal, as I told you, vertical. We have some indications here for the autopilot flight director system, but I will change in a couple of seconds. You'll see the engines here. You can see the engines. We have the fuel control, left and right engine, fuel flow to the engine. We have the fire extinguishers, left and right, pull out and switch, the transporter, radio and communication panel, the radar trim. So this is also, as I told you, the speed brakes over here, pull external retract, the flaps, external retract actually and extend, the thrust levers. We have the auto throttle disconnect here. You press this switch, you disconnect the auto throttle, take off, go around, thrust reverse, pull up. Over here the mouse pad. We have also here some other indications, some other switches. So we have the landing gear extender retract, alternate gear over here, lock override, standby instrument display, auto brakes here, arm the auto brakes, reject the takeoff, or you can see for landing. So I will show you also the overhead panel here. A few more minutes left. The pressurization from the engines over here, automatic, use the manual. You will see what they display. Over here we have the FADEX. The FADEX are the full authority. These electronic control computers I'm gonna talk to you about now. So we have the GNX engines installed in the Boeing 787 hybrid jet aircraft, one in the left wing, one in the right wing, for symmetrical thrust and data. Since one contains a gearbox with the FADEX controlling display of the engine data. You see the upper and lower ACAS, the N1, which is the low speed throttle, have low pressure compressor into one of the two which is the engine left and right. The exhaust gas temperature per engine, the N2, which is the high speed throttle, have the high pressure compressor into one of the two front with the engine, the fuel flow per engine per hour, 1000 kilograms, 1000 pounds, hold temperature quantity, vibration of the two stages of the engine. Also the outflow air, the pressurizer from the engine. So we have an overpressure and under pressure. We can open and close the outflow valves to higher low position. Also the outflow valves from the fuel line stage and from the front stage, which are controlled by the FADEX, the full authority electronic control computers. The engines also supply other systems like the cabin pressurization, the oxygen regulation inside the cockpit and the cabin as we fly, air conditioning ventilation, also hydraulic fluid tanks pressurization. All the hydraulics of the aircraft are pressurized with the air coming from the engines. I'm gonna show you what they do. Also the wing and engine anti-ice, we need hot air from the engines to de-ice the aircraft. Also the FADEX control the fuel on board in the left and right wing, and the center tank is recirculated during the flight into the engines to heat up the fuel, so it won't gonna freeze, because as we fly we're gonna be flying to temperatures lower than minus 37 degrees. In flight is gonna freeze the fuel. Also we do the same for the oil and the lubricant. We have the oil recirculation, the fuel recirculation system into the engines to duct heat from the engines and heat up the fuel and oil, and this is controlled automatically from the FADEX. Also, as we're gonna be flying, as we're gonna take off from the sea level or the airport elevation, and we're gonna be climbing higher and higher. As we climb higher to like 20, 30, 40,000 feet above the sea level, or 9,000, 10,000, 11,000, 12,000 meters above the sea. The pressure of the air, the oxygen level, and the density of the air become less than half than that of the sea level. Also, as we climb higher, the temperature of the air becomes freezing, like minus 40, minus 50, minus 60 degrees below Celsius. Also, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So we're gonna have a different fuel mixer request every second as we're gonna be flying higher. Also, because of the higher airspeed, we're gonna have higher intake of air into the engines, airflow from the front fan. So the fuel mixer is controlled automatically from the FADEX fuel metering unit, oil heat exchange sensors and fuel heat exchange sensors, other data. Also, as we descend back to the airport for landing, We need a different fuel mixer regulars every second, not like in the turboprop or trainer aircraft, which is done manually. This is done automatically, so it's a good thing to have the products installed into your engines. Also, as I told you, engine starters, upside down, engine failures, the hydraulic fluid. So as you see, I moved the flight controls around the yokes for the elevator to climb, descend the aircraft, and make turns. The thrust reversers for the engine, landing gear extender, retract, nozzle string, rudder pedals, flaps, slots, speed brakes. So all the flight controls you see here are moving using hydraulic power pressure from the hydraulic system over here, as you can see. Which needs also pressurizer from the engine. We need the APU also to start the engines in a couple of seconds. You will see also we need a couple of minutes for that. I will show you the autopilot flight director system panel a little bit more in detail. You can see over here engage, disengage, auto throttle left and auto throttle right, autopilot, the airspeed over here. We're gonna set the airspeed guidance of the aircraft as we're gonna be flying. 250, 23. We have the LNAV and the VNAV from the flight management computer, which will be followed by the autopilot when we fly. We have the flight level change, auto throttle climb continues. The flight director, if we turn off the flight director, we cannot rearm any mode or the autopilot. We need the flight director on all the time. We can turn off mode. This is the autopilot engage, autopilot disengage over here. So this is the airspeed guidance, the heading and bank angle limiting flight. We set the bank angle limit, how steep turns. We're gonna set the heading 136 degrees magnetic north pole heading. We're gonna set the altitude thousands of feet over here, then hundreds, so you can set whatever you want. And we have the vertical rate of descent over here, or the flight path angle. You can see a minus sign is a descent. Level off, the zeros all climbed like 3,500 feet per minute. You will see everything displayed. We have our localizer and approach for autoland function over here, airspeed and altitude selected. We have also the engines indication, I forgot to mention, N1 low speed starters have low pressure compressor, N2 bandwidth 0.1% engine, left and right exhaust has temperature per engine, N2 high speed starters have high pressure compressor, N2 bandwidth 0.1% engine, fuel flow principle around 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the input stage of the engine, the outflow valves for the cabin pressurization supplied from the engines, cabin altitude, rate of climb, differential pressure, landing altitude, gross weight for takeoff. So we're gonna have, as I told you, air data computer, GPS receivers, laser reference, and laser gyroscopes, magnetic north pole, graph north pole. So this is pitot static and pitot dynamic, or the air data of the aircraft you see as it flies, the airspeed, parametric altitude, altitude difference. GPS receivers is the air data computer over here. Flight control surfaces. So you see primary flight control computers in the auto position, electrical battery, left and right engine IDZ, the gray drive generator, left and right engine, 120 200 volts, 400 Hz frequency, 120,000 kilovolts. We have towing power, FD, door over here. We have the passenger oxygen, window heat, and over here rammer turbine for standby hydraulic power. Left and right hydraulics off. You'll see the fault displayed over here. So we turn back to on the left and right primary and the mount engine driving. We have the electric also over here, C1 and C2. We have here the recorders for the flight, cargo and APU fire, electronic engine control for the engine with the auto start. You can see the normal and the alternate mode of the engine. We can dump some fuel to lose weight in flight. To make an emergency landing, select the nozzles and how much fuel to remain. We have the left and right wing fuel booster pumps. Crossfeed valve, we can feed either engine with either pump or either tank and balance the fuel between the left and right wing. So we use whatever we need. The wing and engine on the ice over here. We have also the lighting system here and the windshield wipers. Cabin pressurization here. Use the outflow valves, climb and descend in the manual or use the auto. We have also the packs from the left and right engine, pressurizer. Also from the APU we need to start the engine. You will see in a couple of seconds how we're gonna make an engine start demonstration. So we left only one thing here before going into flight, the systems display. You will see here we have the hydraulic, APU, oxygen, liquid cooling, the electric, left and right engine, IDG, APU, load set, the batteries, 31 volts and the average of the batteries. You can see the drive 130 to 100 volts for 100 Hz frequency. Hydraulics, where the hydraulic fluid goes, which system use it. You can see the primary and demand, electric 5000 and 5000 and 5000 psi. Set of valves, fuel, left and right wing, fuel tank, crossfeed valve resolved, but you can feed either engine with either pump or either tank. We have balance between left and right wing. APU is fed from left when using this model. Long high pressure fuel valves are open and feed the engines. We have 11,000 left and right wing and 11,000 the center, total of 33.9 thousand, 33,900 pounds, and a minimum fuel temperature over here below which the fuel will freeze in flight, minus 37 degrees, and the fuel temperature right now. So we will recirculate the fuel in flight. The oxygen and temperature, the doors are closed, the cabin can be pressurized, the landing gear, pressure of the tires, temperature of the brakes, flight controls over here. So we move the flight controls. You will see everything is working in the display, like the horizontal and vertical tail, the ailerons and the spoilers, surface display, maintenance, circuit breakers again, maintenance. So we have the checklist, last thing before making engine start demonstration. So you see normal menu before takeoff, after takeoff, what to do. So we use the NDNKN. We're gonna shut down the engines, make an engine start over here demonstration. So you will see both controllers here in the off position like this. You will see the fuel flow will be off over here. Some warnings, the engines are off. The fuel pumps are not working, so you can see over here we're gonna restart the aircraft. You can see the hydraulics, the spoilers are retracted automatically. So we have here the electronic engine control, auto start over here, both left and right. You can see the yellow reconfiguration in the overhead panel. So we're gonna have the auto start now in a couple of minutes. The N2 above 20%. You can see we have pressurizer right now into the engines. So we need to restart over here the fuel control over here, as you can see. So we have the auto start again, kicking in, 38%, 39, 30, 31, 34, 35. So we have the engines are almost running. You will see the systems now going from amber to other color. 55, about 60% we have the running engines. So we have running engines. We can go for takeoff. So retract the flaps, parking brakes off, advance the thrust levers, and we are going for takeoff over here. As you can see, So we take the clearance from the aircraft control. We align with the tiller here, the center line, as you can see. And we use full takeoff power for takeoff. Advance the thrust levers here, full takeoff power. And pull down a little bit the yoke until 100 knots. Align with the rudder pedals also. So we have 100, 110, 100 V1. So rotate slightly. Have the V1. We rotate in V2. So we climb. We have a positive rate of climb over here. So this is the positive rate of climb of the aircraft, as you can see. So we are 2,400 feet above the ground. The airspeed is 180 knots. You can see the mode's arm. So we climb with 4,900 feet per minute. Here is the stall speed of the aircraft. You can see the terrain below you. When you fly, you have to pay attention to that. Here is the terrain. Here is the aircraft 4,000 feet above the ground. So you can see also the terrain here. We have the engines indications also. The pitch attitude of the aircraft, so you need to decrease the pitch attitude over here. So here we are just after takeoff, and we have 15 more minutes for this flight. So we have the Switzerland here, beautiful view, the lake. So we need to start making the turn. You can see we will be following the flight plan over here. You can see further away also the navigation display, as I told you, the range. You can see the waypoints we have to cross through over here. You can see also the flight plan here. So this is a nicer view over here of the cockpit just after takeoff. You can see. Of the Boeing 787. We keep flying, 12,000 feet, we keep climbing. So we have the most beautiful view you can see from the Switzerland, the Swiss Alps, the Germany, in front of me, my homeland, the France, the Italy. So we have the Boeing 787, the most beautiful, perhaps, airliner, jet aircraft, as you can see, with the beautiful jet engines and the wings. So we're gonna be keep climbing over here, and we're gonna fly through the most beautiful view, the galaxy, also the star sign, and some other aircraft. So you can see also the airport below us as we keep climbing. Have to make a turn here. So you can see the indications, you can see 143 knots, the stall speed is pretty much 110 knots, the warning. You can see also the flight plan we have to follow, the engines, the autopilot here as indicated, and also the head-up display. So we cross 18,000 feet over here. 19. We'll be having here the most beautiful view. You can see this way is the France, the Italy, the Switzerland over here below, the lake, beautiful lake in front of us, the Germany, my homeland, the Bayern Munich, um, and the galactic view over here, Boeing 787, beautiful airliner. So keep flying. So maybe we're gonna make a turn now. We have 11 more minutes to go back to the airport. So we keep flying. Almost more minutes. You can see also the turn that we take over flying over here, the lake and the Switzerland, the Germany, the France, the Swiss Alps again. So this is the lake and the Boeing 787. So we're gonna make the turn here, also use some right rudder over here to anticipate the turn rate. So we have a few more minutes to go back to the airport. Also line with the flight plan here. So we have this beautiful view. We'll be having maybe a few more chemtrails in a couple of minutes. We need 9 more minutes to start the descent over here. So we'll be having the chemtrails. So here they are, the frozen vapors from the aircraft engines, as you can see. Also the lake behind us, beautiful lake, and the France on this side. So this is the most beautiful chemtrails you can see as we overflying here this beautiful place, and we are almost level off on this altitude. The France on this side, the Germany behind us over here, and the Switzerland. So hope you like the chemtrails and the galaxy view. So we need to start the descent now. We have a few more minutes to go. So descent also retract the flaps and going up a little bit faster. We have 7 more minutes left. So idle thrust, also speed brakes extend. So we are flying the airport here. You can see the blinking lights. As positioned here in the navigation display. This is the GPS. We need to see it the descent now. Crossing. And we have about 6 more minutes to go. Increase also the airspeed. So we're gonna make a quick descent over here. A nicer view of the cockpit again. As you can see, all the displays. Also the other side display. And start also the turn. A couple of seconds. Idle thrust. Let's see idle thrust. As we are descending, increase the rate of descent again. Over here. And we have 5 more minutes left. So we start the turn now. We need to turn to the waypoints over here. As you can see them displayed. To enter over here the approach for landing. So you can see we take the turn over here. Use a little bit left rudder now for the turn. To align with the runway a little bit faster. As we are descending. So maybe landing gear down, and we make a small shortcut over here to reach the runway a little bit faster. Make another turn over here, as you can see. So we are here in the runway position. We need to align only. Use also some flaps, some pit stream over here. We're gonna pit stream the aircraft in the positive rate, and we're gonna be having also the approach and landing. This beautiful view. So we need to align. We have some side wind, as you can see. We need to combat the side wind from time to time, because it makes the aircraft offset its trajectory to the runway. So we use manual flight controls, manual engine power, thrust over here available. Also use full flaps for approach and landing. Use some horizontal trim, stabilizers. So wind, we have some side wind and a lot of wind gust, and also wind shear as we approach. Wind gust means also wind shear. So you can see as we are approaching, we need to pay attention. The flight controls use the control wheel, aileron spoilers, and the rudder pedals to align the aircraft to the runway center line. You can see also we have all the Lszh localizer, the information here as we are descending, the airspeed, the altitude above the ground, the localizer. So we follow the Lszh localizer for approach and landing to the runway over here. So hope we're gonna make it easy, not too much turbulence. This also means some turbulence maybe. We have the side wind, wind gust, and also use a little bit less thrust now. Increase the rate of descent again. Flight controls for alignment. So we're gonna be having the flare in a couple of seconds of the aircraft. So here is almost ready for the flare. We need to align out the runway. So we're having the flare, very beautiful flare and touchdown, as you can see. Beautiful flare and touchdown. Very professional. Parking brakes, idle thrust and thrust reverses over here. So we're slowing down, as you can see, and we maintain the center line with the rudder pedals. So you can see idle in the reverse, and we're slowing down. You can see the aircraft is beautiful, safe, very beautiful landing. You can see all the wheels over here. The nose wheel is perfectly safe. There is no breakage of any part. Also the landing gear behind it, as you can see. We can use the aircraft again for one more flight. You can see all the tires. There is no breakage, and the aircraft is starting up the way it should be in the runway over here. So you can see also we can set thrust reverse idle over here. You will see thrust reverses retracted, everything in the cockpit normal. So that was Thomas Hatsios, German American pilot flying the Boeing 787-900. Nice flight. Thank you for watching. I'll see you next time. So you see here